Hi, I'm Chunji Zhao from the University of Tokyo and now a PhD student at User Interface Group. I'm giving the talk in Tokyo from Tokyo and with my cat. In fact, she is in front of the camera. If it if she appears in the camera view, please don't be surprised. Um, I'm here to talk about our prototype tool. It is an educational interactive machine teaching tool that users can use it to train autonomous game agents. Um, interactive machine teaching has attracted attention these days because it enables end users directly interacting with machine learning models and easily creating applications even without the help of machine learning practitioners. In the usage scenario of an interactive machine teaching system, end users just create the dataset by interactively labeling some data, select model parameters, then they can easily train a machine learning model in provided scaffolding. A good example of interactive machine teaching is Teachable Machine by Google, which is a learn by doing tutorial that enables novices creating machine learning applications using web camera and microphone. Actually, the common process of interactive machine learning that users collect the data by demonstrating data labeling can already be familiar to researchers at the intersection of HCI and programming languages, which is regarded as programming by examples. With programming by examples techniques, users similarly do not explicitly write code, but provide examples that indicate the program's functionality. Then the PBE system automatically infers the program by analyzing these examples. Here are examples that utilize programming by examples in data transformation and robot dancing. Um, Interactive machine teaching and programming by examples share many characteristics, which are indicated in the bold processes in the two flowcharts here. First, they both receive some forms of data as input. Next, they construct the implicit computational artifact with input. And finally, users evaluate the artifacts by executing them. However, the key difference is the process to construct the computational artifact is more customizable and flexible in interactive machine teaching. Users can adjust the algorithm of learning, the steps to process the training data, and the hyperparameters of training process. And to be more general, we can further find mappings between traditional software engineering and machine learning development. For examples, programming languages in traditional software engineering correspond with machine learning libraries. Compilers or interpreters in general purpose programming correspond with learning algorithms in machine learning. And output of traditional software engineering is functional softwares, which correspond with trained models learning from data in machine learning. So in this sense, researchers can emulate the design of assistive tools for general purpose programming to promote tools that can help machine learning development. Particularly for lab programming, existing work combines compilers, editors, and debuggers all together and provide human-in-the-loop development experience. This can be inspirable to future interactive machine learning development tool designers. Similar to general-purpose lab programming, interactive edit and evaluation is the key of interactive machine learning and can be regarded as lab programming in a broad sense. People edit data and the models to get rather than writing code. That is the programming in machine learning age. So, inspired by these ideas and a teachable machine, we propose the tool to promote machine learning literacy among people outside of computer science. It is a learn by doing tutorial, which is more well received from a form of a curriculum to novices. We utilize interactive machine teaching in our tool design, just like existing educational programming tools that adopt live programming. We pick gameplay agent training as our application because almost all existing educational machine learning tools are designed for recognition tasks. We choose the game snake and embed it in our current implementation. This is a 4x speed video that to show the game implementation. And then under the snake game, we provide a progress bar, which enables the users to check the frames of recorded gameplay. They can also drag the selection range to trim the important parts, then populate a new gameplay report. Now users can select some desired gameplay reports as the initial training data. They can also adjust the model's hyperparameters, then start to train the model. After around 10 seconds, the training is over, and now users can click the agent play button to test it out in the game. When the agent is playing, users can now observe behaviors of the agents and analyze the causes of some abnormal behaviors. To further iteratively improve the agents, they can trim useful parts from the gameplay by the agent or deeply tuning the model parameters. Yeah, that's the demo video of our tool implementation. And currently, we implement the tool's whole framework. It supports Snake only, and in the future, we plan to explore other model editor features and more applications. The applications here can be other games or applications other than game agent training. For example, generic UI operating. And to conclude the whole presentation, we have discussed the mappings between interactive machine teaching versus programming by examples, and interactive learning development versus conventional programming, as well as interactive machine learning versus lab programming. And then we introduced the prototype tool as an educational tool that utilizes interactive machine teaching. Yeah, that's all.
Thank you. We have time for one question. Okay, I have a question, Chenqi. Can you tell me about how using this tool has impacted the class that you mentioned you're involved with, or how you can imagine it would impact your class in the future?
Pardon? Could you please rephrase your problem again?
My question is about how the tool that you discussed here has had or will have an impact on the class that you mentioned that you were involved with.
So the target user we like to involve with are those students, or maybe the secondary school students or undergraduate students who are without computer science background, and the very initial intention of the tour is to deliver the basic concept of AI development to these kind of users. These concepts includes that the machine learning development is an interactive process, and machine learning development is to create a model, and the model is data plus learning algorithm. So to deliver these kind of concepts and help students under this kind of this sort of concepts is the objective of this tour.
Great, thank you.
Yeah.
Thanks, Junshi.